Hello, my name is Tristan Kelson, and today we are going to be discussing converging-diverging nozzles. Now, the first question we may ask is, where are they used? They are commonly used in ramjets, scramjets, and rockets in order to maximize the thrust output by creating supersonic velocities, because it is impossible to create supersonic flows which contain Mach numbers greater than 1 in convergent nozzles. Here on the right, we can see an example of a rocket and a scramjet. The second question we may begin to ask is, how do they work? Well, hot exhaust leaving the combustion chamber converges to the minimum area of the nozzle, as shown here. This throat size is specifically chosen in order to choke the flow, where the Mach number is equal to 1. Downstream of the throat, as shown by approaching this way, supersonic Mach numbers are achieved due to decreases in static pressure and temperatures at the exit. Again, we are able to achieve subsonic to supersonic flows. Isn't that awesome? Now, the exit temperature determines the speed of sound at the exit, which then determines the exit velocity. The exit velocity, pressure, and mass flow rate can then be used to determine the amount of thrust produced. Now, continuing on with our discussion on how they work, we can look at this graph depiction. As discussed previously, we know that the velocity increases as you move across the nozzle, where the fluid changes from subsonic to supersonic. In addition, by looking at the image above, we can see that the area changes according to the following trend. It decreases and then begins to increase after the throat. Now, also, in order to conserve mass in supersonic flow, both the density and velocity are changing with area. This can be shown with the curve here. Now, in order to conserve this, the density must be decreasing faster than the velocity increases. This is done to conserve both momentum and mass balances.